should go that way, but if I put it above, right, then it's the other way, isn't it? That's kind of fun, isn't it? Now let's take the South Pole. Shouldn't the magnetic field be going into the South Pole? Right, so now velocity this way, magnetic field that way. It should go up. It'll go negative up, so therefore down. Yeah? Little applause for physics laws that work. And then, you know, don't ask the awkward question, why does it do that? I don't know. It's just the way, it's a fundamental law, right? Okay.
Why?
I don't know. I don't know. And I don't know where babies come from either. Yeah. Say it again. Oh, centrifugal. All right. So let me do an example. I'm going to do an example problem with our new formula. Okay. So here's a proton. Protons are our friends. This proton's traveling through a region where there's a magnetic field out of the page. That's what the dots are. Okay? And so this proton, it's like, boy, that's going to be a lot of dots, right? I got to draw 16 dots. Okay? This proton is traveling to the right in this region. Okay? Now, the force on that proton is index fingers this way, magnetic field finger out of the page. The force is going to actually be at right angles. If this is the velocity, the force is going to be at right angles, right? And I'm going to use my formula. F is Q VB sine theta. I'm going to assume that theta is 90 degrees, especially since the proton is in the plane of the page and the magnetic field is perpendicular to that plane. Okay? Now, the charge on a proton is, well, 1.602 times 10 to the minus 19th coulombs, right? And the velocity that it's going is 4787.81, which is a curiously accurate, right? It's like, boy, we really know the velocity of that thing. That's amazing, right? Okay, and that's meters per second. And then, let's see, QVB, we got to say B. So Earth's magnetic field is apparently 5.0 times 10 to the minus 4th Teslas, right? And then sine of 90 is 1. And so we get our force to be one, clear, quit, okay. 1.602 E minus 19 times 4787.81. There must be some reason why this is so precise, times 5 E minus 4. And I'm getting a force of 3.835 times 10 to the minus 19th newtons. Yeah? Did you? Oh, E minus 5. Yeah, okay. All right. Smart aleck kids. There we go. Are we good so far? Yes? Now, the second thing, and this is sort of an interesting thing, is that that force is at right angles to that velocity. Is that going to speed it up? Can a force at right angles to the velocity speed it up? No. Is it going to slow it down? No. Is it going to change the velocity at all? A force, an unbalanced force, is not going to change the velocity. It's not going to change the speed, I would agree with that, but I think it's going to change the velocity. Yes? I think a force at right angles to a velocity changes the velocity, doesn't it? This force is at right angles to this velocity, isn't it? Yeah. It's changing the velocity. This velocity is constantly changing, isn't it? Not the speed part of the velocity, but the velocity is what? Speed and It's going to be a long IB test for you guys. Isn't it speed and direction? Yeah, speed and direction constitute velocity. Change either one, you've changed the velocity. Either one requires a force, yes? On an icy road, your car doesn't do either one. It doesn't change its speed or velocity very easily, does it? Yeah? It doesn't go around corners very well. It doesn't speed up or slow down very well, right? We've got to plan ahead, drive slowly, drive cautiously, right? So what is this force going to do? It's going to make this proton do what? What did the string make the tape do? Change direction. And specifically, it did what? It's going to go in a circle. Yeah, this thing's going to go in some nice little circle. Like that. That's a fairly good circle, right? Okay. It's a little off, but it's pretty good, right? This thing is going to go in a little circle like that. Now, what we tend to do then is we actually tend to set these things equal to centripetal force. So it's very, very common. There's a lot of formulas where it's QVB equals mv squared over r. What is mv squared over r? Well, this is, it's like v squared over r is centripetal acceleration, remember? Yes? And m times centripetal acceleration is centripetal force, right? So magnetic fields make moving particles travel in circles. Almost every problem you solve is going to be that, is to figure out the radius. So let's go ahead and figure out, what this thing's going to do. Yay. Okay. So let's figure out actually the radius that this thing's going to travel in, right? So I'm just going to do this. I'm going to say QVB equals mv squared over r, right? Let's solve this for r. Can't we can cross off one of the v's, can't we? This is interesting. This is sort of interesting, right? What you get in the top is the momentum, don't you? Right? And then if I just put QB down there and r up there, I end up with r is mv, the momentum divided by the charge times the magnetic field, right? So the radius of this thing, the radius it's going to go around, this is a proton, right? Okay? And we would have to look this up, but it's going to be, what is it, 1.673, is it? E minus 27 kilograms. Okay, the velocity is 4787.81 divided by 1.602. Okay, and then the magnetic field is apparently 5.0 times 10 to the minus fifth Teslas. Contrary to, that's coulombs, this is meters per second. So put that in your calculator and calculate. Let's see, divided by 4787.81. Whoops, did I divide? I need to multiply, don't I? Okay, multiplied. Divided by the quantity, 1.602. Bless you. Times 5e minus 5, end quantity. So if you're going to do this, remember, if you're going to do it all in one swell swoop, put the entire denominator in parentheses. What do you get? Is it 1.0000, some incredible amount of zeros? It's like 1 meter. Do you suppose I cooked this up so that it was like exactly a meter? No, they all come out to a meter. I'm kidding. I'm kidding. Like, somebody's going to remember that, right? 1.0 meters. How many sig figs do we have? I don't know. 3 sig figs. 1.00 meters. Ta-da. I cooked it up. I cooked it up. So let's do a couple things. Let's practice first figuring out the direction that these things are going to spiral. Right. This will be like the final row of our pre-quiz that we did. Right. Let's practice using that formula, and then I've got something exciting called the Hall effect, which is very exciting. Right. Okay, so proton, everybody, let's breathe through it. The proton is going that way. Magnetic field is out of the page. Force is going to be to its going to be down, right? So isn't it going to spiral down?